Section 16, question 2. Part A. Show that the line with equation y equals 3 minus x is a tangent to the circle with equation x squared plus y squared plus 14x plus 4y minus 19 is equal to 0. And find the coordinates of the point of contact. So for shown tangency, I'm going to first of all sub y for the straight line into y in the equation of the circle. So wherever I see y, I'm going to replace it with 3 minus x, so that'll be x squared plus 3 minus x all squared plus 14x plus 4 lots of 3 minus x minus 19, and that's equal to 0. So just be careful when you expand this stuff out. So x squared plus 9 minus 6x. If you need to go to the side, I would advise that you do that. Plus x squared plus 14x plus 12 minus 4x minus 19, and that's equal to 0. So tidy it up. X squared plus x squared is 2x squared. Minus 6x plus 14x is 8x. 8x take away 4x is 4x. 9 plus 12 is 21. 21 take away 19 is 2. And I've got a quadratic equation which is 2x squared plus 4x plus 2 is equal to 0. So I've got two methods to prove tangency here. Discriminant is one method, and if the discriminant is equal to 0, then that would prove tangency. Second method is to factorise to get equal roots. I'm going to use that method because the question also looks for the point of contact, and that gets me started with that one. So first rule of factorising is highest common factor. So 2 bracket x squared plus 2x plus 1 equals 0. I can then cancel the 2. So two numbers that multiply together give 1, add together give 2, that's 1 and 1, so x plus 1 all squared is equal to 0. So equal roots, x equals minus 1, therefore tangency exists. Question's also looking for the point of contact. So just get my value for x, which was minus 1, and sub it into y. So y is equal to 3 minus x, so that's 3 minus minus 1, 3 minus minus 1 is 4, so my point of contact then is minus 1, 4. So I filled that in just in case I need it later. So part B now says, relative to a suitable set of coordinate axes, the diagram below shows a circle from A and a second smaller circle with a centre C. The line with y equals 3 minus x is a common tangent at the point P. The radius of the larger circle is 3 times the radius of the smaller circle. Find the equation of the smaller circle. Right, remember to find the equation of a circle, two things you need are the circle centre and the radius. So I'm going to first of all attempt to calculate the radius of the smaller circle. Now, to get there, I know that it's 1/3 of the size of the radius of the bigger circle. I can get the radius from the bigger circle easily by square root of g squared plus f squared minus c. So that will be the square root of 7 squared plus 2 squared, and c is minus 19, so minus c would be plus 19. That's square root of 49 plus 4 plus 19. That's root 72. So remember, for surds, you'd be expected to simplify that. So thinking about my square numbers, 36, and that's 6 root 2. So the radius of the bigger circle is 6 root 2. So I can say that the radius of the smaller circle then must be 2 root 2. So I'm halfway there. I've got the radius, I'm now going to try and find the circle centre for the smaller circle. I'm going to use a wee bit of vectors to get there. So I'm going to call the circle centre here t for the bigger circle, and half an invert, that will be -7, -2. Now what I can then see is, since TP is the radius of the bigger circle, and that's triple the radius of the smaller circle given by PC, I can then put down a relationship which is TP is equal to 3 lots of PC. So that's P minus T equals 3 lots of C minus P. Now the object of the exercise here is to find the circle centre C, so I'm going to eventually try and change the subject formula to C here. I'm just going to swap this round, so it's going to be 3C minus 3P is equal to P minus T. I'm going to bring that across, and 3C would be equal to 4P minus T, and C would be equal to 1/3 of 4P minus T. C is equal to 1/3 of, so 4 lots of the vector P. So vector P is given by the point P, which, as we can see, is -1, 4. T was given by -7, -2, so I'm going to feed that back in. So -1, 4 minus -7 -2. So 4 lots are -1, 4 is -4, 16 minus -7, -2. That's 1/3 of -4 minus -7 is -4 plus 7, that's 3. 16 minus -2, 16 plus 2, that's 18. So 1/3 of that is 1/6, which is the point 1/6. So the circle centre is given by 1/6. We've seen that earlier on that the radius was given by 2√2, so we can now feed that into x minus al squared plus y minus bl squared is equal to r squared. So it's going to be x minus 1 all squared plus y minus 6 all squared is equal to 2√2 all squared. We don't need to expand this out. There was no call for that in the first place. The question didn't insist that we do that. So we're going to square 2√2, square 2 and you get 4, square root 2 and you get 2, 4 times 2, and that's 8, and that's the final answer to the question.